Solve the following reaction. Well, in a reaction like this, when we're working with water, it is typically also done with heat to help catalyze the reaction. Now, water acts as a weak base and a weak nucleophile, which would mean it would undergo the reactions SN1 and not SN2, E1. So it would undergo SN1 and E1. So we need to find the products for both of these. Now we're also working with a second-degree alkyl halide, and chlorine isn't all that reactive in SN1 and E2 reactions, but in this case it will react. But if you had the option of which one would be most reactive, and you were shown bromine, for example, bromine is more reactive to SN1 and E1 reactions. Now, when we're working with SN1, we're gonna get a carbocation intermediate here. Now, in this case, this can form substitution where that current carbon is. So we would get OH here, or we would get the more common methyl shift. And so that would produce this molecule right here, where the alcohol is forming on that tertiary carbon. So those are going to be our SN1 products. And then as for E2, we're gonna get something very similar. When we have our carbocation, right, carbocation here, there's 4 carbons here, so it can eliminate just like this in the Hoffman position, or it could undergo a rearrangement. Oh, drew that a little bit wrong. Get the methyl group up there, 1 methyl group here, and it would eliminate kind of resembling Zaitsev in a little bit of a manner. And so that would be our E1. Now, one of the E1s is going to be way more stable than the other. So our one on the top is our minor, and the one on the bottom is our major. And then I'll just block this off so people can see the carbocation rearrangement taking place. And that is how you solve this problem.